So good morning all. So in today's class, we will see an example of how to solve a homogeneous linear differential equation. So using eigenvalues. So let us see an example. So find the general solution of the system. So we have dx by dt equal to 6x1 minus 3x2 and dy by dt equal to that is dx1 by dt and this is dx2 by dt equal to, so we have 2x1 plus x2. So let us see how to find the general solution of the system. So here uh, this is a case where the roots of the characteristic equation are real and distinct. So uh, the coefficient matrix, so A will be here 6 minus 3, then 2 1. So let us find the characteristic equation. So the characteristic equation is given by determinant of 6 minus lambda minus 3 2 1 minus lambda equal to 0. So that gives 6 minus lambda into 1 minus lambda plus 6 equal to 0. So therefore 6 minus 7 lambda varum plus lambda square plus 6 equal to 0. So therefore lambda square minus 7 lambda plus 12 is equal to 0. So the roots are going to be equal to 3 and 4. So lambda value is 3 and 4. So the eigenvalues are, so they are real and distinct. So now we will see the corresponding eigenvectors. So when lambda is equal to 3, so we have the equation a minus 3i x equal to 0. So upon solving this we will get the eigenvectors. So that is 3 minus 3 varum. So 3 minus 3, then we will have 2 and 1 minus 3 varum 2 varum, minus 2 varum. Okay. So it will be equal to 2 and minus 2 x equal to 0. So the two rows are multiples of one another. So this implies, so when you simplify row reduce AMO, you will get in the equivalent form 1 minus 1 0 0 x equal to 0. So that implies x1 minus x2 is equal to 0. So let us put x2 equal to t. So therefore x1 is also equal to t. So therefore eigenvector, so you have x1 x2, so that will be t times 1 1. So the eigenvector is so let us call it as capital X1. So that will be the vector 1 1. Okay. So that is the first eigenvector. Now when lambda is equal to 4, so the equation is a minus 4i x equal to 0. So that will give us, so 6 minus 4 2 varum, 6 minus 4, then minus 3 2 minus 3 2 and 1 minus 4 is minus 3 x equal to 0. So that again implies, so the rows are multiples of one another. So x equal to 0. So we will get the equation 2x1 minus 3x2 equal to 0. So let us put say x2 equal to t, so that implies x1 equal to 3t by 2. Or if we can take, so multiply with 2 throughout, so x1 is 3t and x2 is 2t. So therefore eigenvector is, so we can take it as 3t, 2t. So therefore the eigenvector x2 will be, so that will be the vector 3, 2. So now we have got the eigenvectors. So eigenvectors are 1, 1 and 3, 2. So therefore the general solution is, so general solution will be x equal to c1 e raised to lambda t. അപ്പോൾ 3t വരും. Then the corresponding eigenvector is 1, 1. Then plus c2 e raised to 4t into corresponding eigenvector is 3, 2. So that is equal to, so the general solution will be c1 e raised to 3t plus c2 4, 3. So we will get 3 e raised to 4t. Then you will have c1 e raised to 3t plus 2c2 e raised to 4t. So therefore we have x1 of t equal to c1 e raised to 3t plus c2 3 e raised to 4t, and x2 of t is equal to c1 e raised to 3t plus 2c2 e raised to 4t. So this is the general solution. So when the roots are distinct, this is how we find the general solution. അപ്പോൾ ആദ്യം corresponding eigen characteristic equation എഴുതുക, corresponding eigen values അതിൻ്റെ corresponding eigen vectors കണ്ടുപിടിക്കുക. So general solution will be of the form c1 e raised to lambda t into x1 plus c2 e raised to lambda to t into x2.